So, hey everybody, with us today we have Ashley Walker. She's currently a research assistant at NASA's Goddard Space Flight Center, focusing on the chemistry of planetary atmospheres. She was recently the first Astrochemist graduate in Chicago State's history. Incredibly impressive. And she's a frequent presenter on space at the Adler Planetarium in Chicago, and so much more. Thank you for being with us today.
No problem. Thank you for having me.
For sure. So the mission of Astrolennial is we want to talk to young millennial folks involved in astronomy, see how they got to that journey, some of the things that they're working on. And just to kick things off on that note, can you tell us about your journey of how did you get to NASA? What are some events that sparked and led this journey to where you are today and where you're headed next? And then maybe also start with, what was the first moment when you became enamored with space?
Well, I guess I could kick it off with that question because I wanted to be a moon, but I also wanted my parents to buy me a star out of the sky. And so my mother and my father was like, what did that, what? They were trying to figure it out, like, what? Well, Ashley, we cannot literally buy you a star out of the sky. Like, we just can't buy you a star and just give it to you. Because I'm like, I want that. They're like, no, you can't have that. And so, because I was extremely spoiled. And so my uncle went on ahead and bought me a ruby red telescope. And when he bought me the telescope, I would play with it. Other people would come play with it. My cousins were always at my house. That's just, my house has always been the go-to house. And so my cousins would always be at my house. And we would all play with it together, so on and so forth. And eventually, our aunts every summer would take us to like the Field Museum. They'll take us to Brookfield Zoo, so on and so forth. And so one summer we went to Adler Planetarium, and I wanted to continuously play. I wanted to play there. I wanted to be there, and we stayed there for quite some time. However, there was one exhibit that really caught my eye. It was a scale, and it was a scale with all of the planets. And so if you jump on different scales, it'll tell you your weight. So you can see your weight on Mars, on Venus, on the moon. And so I'm not that big, so therefore my weight probably didn't hold as much, but I was really, really happy to see this. And so my journey was a little bit different because I actually veered away from STEM as a whole. I ended up doing more artsy work. So growing up, I was very, very athletic. So I was a cheerleader, I played basketball, I eventually veered off into dance, which actually I was doing when I was 5, when my uncle bought me that ruby red telescope. I played piano, I played the guitar, so on and so forth. So growing up, I did a lot more artwork than I did STEM work. And so I mostly focused on that, and that's what I wanted to do.
So when you first got the ruby red telescope, do you remember where was the first place you went to look at the sky? Do you remember that moment? Or do you remember seeing anything that really caught your eye through that telescope?
I literally placed it on the moon. I remember exactly, because the way my bedroom was set up is like you had my parents' room in the front, my room was closer to the back, and then my uncle had his room all the way in the back. So you can like open my window and boom, there was the moon, and that's where I placed it, and that was the first thing that I looked at.
Were you surprised with what you saw when you looked at it? Do you remember thinking anything that, wow, this is not what I thought it was? Or
exactly, I just thought like, oh, it was so cool. I was so fascinated, as a kid.
And so you started doing artwork at that same time, like when you were maybe outside of dancing, but the stuff that you painted or drew or that you created, was it in any way tied to space or tied to sort of to your exploration with the telescope when you were growing up?
No, surprisingly, no. I would draw like a lot of family things. I even made my first storybook, which my aunt still has. when I was 5, and I remember the date and everything. And so it's just so crazy. That was like 10 years ago. And so my aunt still has it, and I did not draw space related things until later on. So I didn't like come back to space. I briefly came back in high school. So I had to take chemistry, biology, and earth space science, which is so coincidental, right? So it's so coincidental with what I'm doing today. And I actually ran into my earth space science teacher 3 years ago.
Mm-hmm.
And I had just came back from Harvard after doing my internship, and she and I were talking, and that's when I told her, and she had told me how she retired and so on and so forth, and she had a big smile on her face when she found out what I was doing, because now because it made an impact. You know, you don't necessarily see your students do that work. So,
You know, that's something I want to come back to later when I have a few questions about the planetarium for people of color. Like, I'll ask this question now and maybe we can get into it, or the conversation can evolve this way, but is there a place for art in a planetarium? And
of course.
Okay. So maybe let's talk a little bit about that now. So do you still use art in the way in which you communicate science? Do you think it has a purpose? How can we leverage art and creativity in this field?
So currently I am working on my Black History Month highlights in my Black History Month series, and I'm going to turn them into a comic book, and I want to turn them into a cartoon series. Because, you know, representation is very important, and we want to show representation, and especially for Black and brown children, because they don't often see people that look like them that are scientists. And so we want to show that.
Cool. That's excellent. So for a moment, going back to your journey, you mentioned that you took chemistry and biology in high school, and it was coincidental, but you did a lot of forensic chemistry work before ultimately landing on your path to astronomy and astrochemistry. Can you talk a little bit about that?
Well, I did a little bit, but so I would go and try to like do internships and stuff like that. I would try, keyword try. Keyword was try. And so I would be in contact with, at the time he was the chief toxicologist at the morgue here in Chicago, and at Cook County Hospital. And I've contacted him, and I said, hey, I interviewed him and everything, and I asked him what was his worst case, and he, it was very deep, which I'm not going to get into, but it was very, very traumatizing, and that kind of put something on my brain about, did I want to continue this path? Did I want to continue this path? Now, when I got to Chicago State, because this happened when I was at CSU, I was coming out of junior college going into CSU, so it was the battle of two tails, right? And so I found out that they had a Illinois Space Grant Consortium. And so I said, I saw they had a NASA space grant, right? And I said, it'll be cool to be a forensic toxicologist, a forensic chemist, but it'll be cool to have NASA on my resume.
NASA is very cool to have on your resume.
Exactly. It'll be cool to have it on my resume. I didn't think of it as a career at the time. I didn't think of none of that. Okay. This is 5-6 years ago. So I didn't think of that. Right. And seeing my background from taking those courses in high school and then take them again in college, it didn't really dawn on me like, this is the path that I'm supposed to take. Because in high school, I was so busy trying to be Beyonce's choreographer. So I was too busy trying to do that, right? And so, and that's what I initially wanted to do in college. So
that's really cool. And I mean, when you talk about getting into astrochemistry and pivoting from forensic chemistry, it's another thing we spoke about when we initially connected was that there are actually different types of astrochemistry. So can you maybe educate the viewers, like what are the different types of astrochemistry and where does the work that you do fit in that scale or in those groups?
So when we talk about the different types of astrochemistry, you have observational, which is more so with observatories, and you are just basically monitoring everything that's going on. Now, all astrochemistry works together as one unit. So so again, you have observational, which you're just monitoring, and you're going to observational sites, which I've done observational astronomy before, briefly, but I kind of figured I know where I want to land. I knew where I wanted to land. At first, I was just like, yeah, this is cool, but I don't know if I like being in a remote place.
Can you give us an example of when you did observational astrochemistry?
So when I went to a workshop for the undergraduate alfalfa team, the UAT, which actually next week I have a panel with them as an alum. And so they were teaching us, the basics of observational astronomy, and watching and understanding the data, and getting your feet wet, and doing these observations at night. And now I wrote a thread about it long time ago, and let me tell you all, I don't know if I like the dark like that, because it's like really pitch black. It's pitch black out there. I went to Green Bank Telescope, and they do not, like, there is no like sorts of like, it's very remote. So it's the quietest town in America. So when it gets dark, it gets dark. You only have like one source of internet section there, and then you go back to where you're sleeping. So I was just like, don't know if I can do this, but it was definitely a once in a lifetime experience. And it was actually, and if you're a nature person, it's very beautiful, in which I camped when I was younger. So I was kind of used to this type of this field. But going forward, I am more so an experimentalist. So you have people that do instrumentation. And so instrumentation that I do, I work with Fourier transform, FTIR. And so we want to look at the spectral, we look at spectroscopy, IR spectroscopy, infrared spectroscopy, and we want to understand, like, for example, functional groups. So these are like chemical groups that we think are in these molecules. And so this is the type of astrochemistry you can do. You can do laboratory astrochemistry, aka experimental. And so this is something that I specialize in. I've also done computational astronomy, and I've done computational astronomy when I was at Harvard. And computational astronomy helped me understand that I still want to do computation. It can be rough sometimes, but coding helps us. Building codes helps us, manipulate certain things, and help us understand if there's anything. Give me 1 second. I was waiting on an ambulance to pass. So computational astronomy helps us, build things as if in some cases, a what if scenario. And we can see things if it's a what if type of case, right? Somewhat of an experimental goes into computation, and as well as observational astronomy too. So all of them intertwine together and work together, so we can figure out, is this actually happening? And a lot of the times, voila, we're right. But that's only a small portion of astronomy, again, because we don't know everything in astronomy, but from what, our view and what we can see. So those are the 3 types of astrochemistry, 3 types of astronomy that can be done. And so currently I work on Saturn's moon Titan. Titan has been my beloved, it's been my beloved object in the solar system for the past 2 years. So I'm very grateful for that.
So before we get into Titan and talking about the different types of astrochemistry, when you're thinking about what problem to approach, how to scope out the experiment, or the type of models to build through code, how do you approach the problem? Like space is many problems combined into one. Do you build on prior experiments? Do you try to create or identify new problems? Is it typically a big problem that you try to solve and you back into it? Or is it just like a very small component of something very specific? Can you take us through that process of figuring out the problem that you want to then solve?
So since I work on smaller scale astronomy, I look at smaller things. So I try to build off of previous experiences. So currently what I'm working on now, I'm building, so hilarious that I'm building off an old project and two old projects, my senior thesis and one that I did at Harvard, right? And so, which I worked on ISIS in protoplanetary disks, so in early planet formation. So I'm building those, I'm bridging the gap between those two to help me figure out this new set of issues that, well, not issues, but this new puzzling idea that we want to know, because we're so curious about what's going on Titan. And so using those two previous experiences is definitely helping me understand my learning style. And that's something that I want everyone to know. You have to understand your learning style. I don't care how old you are. You have to understand your learning style. You have to know this. And so if you don't know this, this can't help you grow and help you build. And so I also have to understand the chemistry behind it, because again, I have a bachelor's in chemistry. So you want to understand the chemistry behind what's happening on this planetary atmosphere, or what's happening in this galaxy, or what's happening in this supernovae, or what's happening in this intergalactic ring. So you want to know the background of everything. And so what I typically do is, if it's a certain molecule you want me to look at, I will look at it purely. I'm like, all right, what's the molecule? Oh, it's that. Oh, let's see if it's gonna kill us here.
So let's dig into it a little bit too. Like, what's your learning style? B, how did you figure out your learning style? C, can you give us an example on your work with Titan where you've applied that learning style and discovered something new?
So I work on, so for me, my learning style, I learned the hard way. I had learned the hard way. I had a few traumatic experiences where I had to relearn what I already knew and what I was good at. And so my learning style is visual. I'm very visual, and I'm a listener. So because I'm a listener and I'm visual, I need very, very big things. So in terms of, like, if you have flashcards, for example, and everybody needs flashcards in organic chemistry. I will tell you this right now. That is a course you need flashcards. That in biochem, you need. So I learned with flashcards. I learned with. I also learned by teaching others, which was one of the most important things when I learned as a learning assistant. And so a learning assistant is just like a TA, but we don't grade papers. And so what I learned is, like, when I took PChem, which I honestly took PChem quite a few times, and I finally got it right, because I knew what I was doing. It was just certain things that I was messing up on. And when I took PChem the first time around, my professor just sat back and he watched. He just watched. He was just like, okay, you can basically teach this class by yourself. Because I picked up on things, and it was a certain way that I learned, and I was able to teach my my peers. And so that's how I learned. And so when it comes down to my research, I definitely have to sit down, and I can read, 1,000 papers a day or whatever, but I want to make sure that I apply it in a way that's helpful for me. So if that means drawing stuff, then for the visual effect, then that works for me.
Cool. So what are some interesting astrochemical properties of Titan? What are some things that we hope to discover there?
So we want to know in the future about the haze, because Titan is a jerk. It's a big jerk, and I love Titan,
Mm,
but it's a jerk. We want to know about the haze. We want to know the chemical composition of geological, um, the geological aspect of Titan. We want to know about the sand. We want to know about the possible air quality that's there. We know a little bit about um, its hydrocarbon cycle. Like we have a water cycle here, it has a hydrocarbon cycle there.
mhm,
We do want to know what we want to know more about it, and if it is possible to have water there.
mhm,
That's another thing that we want to know. We know it has um, ice water around like the cap, but we want to know if it's embedded in the actual play in the actual movie, and that's something that we all want to know.
And will those findings help? Like, is ultimately the question is what is Titan's habitability?
Hmm.
What is its possibility to harbor life? Can it give insights into the formation of our Earth? Like, what are some of the driving questions for that research?
Exactly. That's exactly for my experiment. We want to know um, we want to know the chemical composition of its upper atmosphere. And so we want to know about, give me 1 second. I have a little cat that wants to get in.
No.
We want to know more about Titan's upper atmosphere and about what um, we want to know more about Titan in itself. So if we can understand the chemical composition and how Titan is very much similarly to early Earth, this can give us clues to our own early Earth.
Cool. So maybe take us through the process a little bit. Like you have this input data that's being collected through a variety of sources. Like how is some of that data being collected? And then do you and your team take that data, you write the code, and then you process it through these algorithms that you create?
So I don't code. For this work, I do not code. Thank goodness I don't code. Oh my goodness, I would have lost my mind if I did. I would cry. You guys would hear me crying every day if I did. Because I'm still working on my coding skills, and that's another learning style, right? But a lot of people do things um, via remote sensing. And so a lot of people do things via remote sensing, and some people do things experimentally. Experimentally. And so while we're doing these things experimentally, this can help us understand um, a little bit more if we're actually right. Because, um, we look at some of the previous work that has been done and some of the questions that have been asked, and like, okay, we've asked these questions, but what about this set of questions? Are we going, let's drive it home and look at this. And so we want to understand more about Titan as a whole, because again, it's it's a very complex um but interesting body. It's so amazing. And so um my processes, I am looking at data from previous work that has been taken, and so I'm just looking at it. We just want to know if this particular molecule is actually there.
Hmm.
We want to know if it's there,
So,
and
mhm.
and if it's going to um, if it's going to be more of it.
So is there like what's one experiment or one question? Like, is there a specific molecule you're looking for? And you're like, within a year we'll get there, and that'll open up an entire new discussion. Is there something like that that you're focused on right now that you're really excited about happening soon?
I am, however,
Mm-hmm.
we are not there thanks to COVID. Thanks to COVID, we are not, we can't say in a year because COVID has kind of shut us down a little bit. But I want to make sure that hopefully in the near future we can continue looking at this and seeing how it affects Titan as a whole.
So talk to us a little bit about that. Like, you finally made it to NASA, and then a pandemic hits and everybody's working remotely. So what's it like to work for NASA but be remote? What does that team collaboration look like? How does that impact your style of work? And share a little about that.
So I currently work in the SPICE Astrochemistry Lab, and so in the SPICE Astrochemistry Lab, so it's so we're looking at spectral ices on specifically of Titan, but in other but we do have other places that we look at. And so I currently work with Dr. Carrie Anderson and Dr. Melissa Ugolo. And so Ugolo, I'm sorry. And so Carrie and Melissa are really amazing, and I meet with them all the time. So it's like, okay, it almost feels like we've never, like, we're not in a pandemic, but it's kind of hard because, you know, typically I would be in the lab and doing like some coding work. I'll be doing a little bit of both. And so, unfortunately, because of the pandemic, working for NASA has been a little bit more difficult because, I mean, I still attend seminars, I still attend, you know, meetups with some of the other students. I still do certain, you know, social media promotion outside of NASA, such as Black and Astro. But it's just been like, it's still been an amazing experience, and it's still, you know, we're still trying to get through it.
Cool. Well, it sounds like you have a very positive approach towards it. And hopefully, once this is all over, you'll be able to hit the ground running.
Yes.
So you mentioned Black in STEM. What are some causes that are important to you that intersect minority representation and Astro? And like, what are some organizations that you're involved with that promote the causes that you promote on social media or that you're involved in the community?
So currently I am one of the committee members of the CSMA. So that is for the American Astronomical Society, the Committee of the Status of Minorities in Astronomy. That is like a mouthful. So it's AASCSMA. I am one of the first junior members, like one of the most junior members on the CSMA. And so we promote togetherness and how we can push forward in supporting our Black junior astronomers and Black and Brown junior astronomers. And so they've been extremely supportive in my movement, and we're trying to figure out ways that we can work together as a collective, as well as some other places that I collaborate with or that I work with. And a big shout out to the Women of Color Project, who was founded by Linnell Williams, who also, as a collective, work on, you know, helping women of color thrive. And so this is something that, you know, these are practices that we want to see win and that we want to push forward.
For the people watching, like, what are some of the things that they could be doing, especially if they're in this field, whether they're a professor or a TA or a student? What are some things that they should keep top of mind?
So for the non-Black folk, the non-Black and Brown folk, they want to not just promote their students on social media, not just, you know, say Black Lives Matter, not just read books, but actually practice what they learn. And that is one of the biggest things that we all want for them. We all want them to practice what they learn. If they practice what they learn, then this can help us grow as a society and a community.
Cool. Yeah, well, thank you for sharing that. That's very important for people to know, right? Especially during these times of change. So going back to what I mentioned earlier about the planetarium for people of color, this is sort of an extension of that vision coming to fruition. in episode 2, we spoke to Kishan Ivory, and he shared a little bit about this. And both of you mentioned that you two, plus Elizabeth Gutierrez, are planning and working on a vision for an inclusive planetarium, specifically geared towards the POC community. Can you share a little more about that? How do you see that coming to fruition? You know, what are some tenets of that planetarium? What are the steps that it's going to take to get there?
So, well, we plan on hijacking an No, I'm just kidding. No. So, although people have thrown that idea, like hijack a planetarium. Wait a minute now. Um, we've been working on this, and we've been, brainstorming and so on and so forth. We planned on, for all the Black and brown folks who have left astronomy but still have that burning passion, we will be bringing them back home. We will be offering them a place of community, a place of safety, so on and so forth. The vision for it definitely lets us know that, our ancestors were the ones who got us here today. And that is something that, that's our sole mission, because we want to thank them for everything they've done for us. And we want to showcase the brilliance of Black and brown astronomers and how they really maneuvered and changed the field. And we don't often pay homage to Black astronomers specifically who have paved the way for this field. And so, and just who Black astronomers are the reason astronomy exists. And so we don't see that being paid to quite often. And so we want to take it back to Africa to bring it over here to the Americas with and even in our indigenous folks over in Australia and here, so our indigenous folks here, and to people in Asia as well. So we want to show that, we've all done astronomy at one point in time in history. We also want to pay homage to the folks who went through horrific events throughout time, and and represent that these people could have been astronomers, but this had happened to them, and it's not our fault that this happened, right? We want to showcase, how it's important to see people that look like me as an astronomer. And so some of the things that we will plan on having, we will have like a similar Adler After Dark event, which I will be the coordinator of, which I am very, very proud of. And so we also have dome movie theaters. We'll also have, we have an entire vision of things that we want to do and that we want to share with other folks. And we're just really, really excited. We are shooting for 2026. However, if COVID continues, we will have to shoot for a later date. But we're praying and hoping that it will be 2026. And we want to continue collaborating with folks, and we want to still do our astronomy inside the planetarium.
That's a great mission and a great target. I hope you guys hit 2026 so I can visit.
Thank you.
Have you given any thought, and this might be top secret, but who your first keynote speaker would be, or maybe the first exhibit that you would showcase and highlight to bring people in?
Of course, yes, we've thought about all that. We've thought about all that. We actually have the name, but we will not reveal it yet.
Okay.
We have the name. We have the person who will be the keynote. We have we're definitely in motion in what we want to do. And if because some people think that, oh, this is just going to be a one-stop shop. Actually, it's going to be multi-city, and that is a giveaway. That is the only giveaway I'm giving away. So
I won't ask for more, but that sounds great. That's awesome.
It'll definitely be multi-city. And so we want to make sure everyone is accounted for, and that we're showing people that, hey, we love you. and that, we're here.
Cool. So let's end on this question. The way that I came into contact with you, or that I discovered you, is via Twitter. You're very active there. And so somebody stumbles upon your Twitter, would you say they can get a pretty good idea of who you are? Or let me rephrase that question. Maybe what are one or two things that you would want people to know that they might either miss or misunderstand simply by looking at your Twitter?
That's a really good question. Well, one thing I want people to know is that I'm very, very active, and that two things, and that I am very helpful. I think that's two things. Well, I think everyone knows that though, so I don't think that counts. Oh, I gotta repeat this. But no, I seriously, I think most people, when they come on my Twitter page, they're like, "Oh, she's highlighting Black folks, or she's highlighting folks," and so yes, I highlight folks all the time. So that's something that I do want folks to know. I do want folks to know that I am pretty active in just helping others understand what is astronomy, what is astrochemistry, more so. And I'm building a community.
Cool. Well, Ashley, I just want to say thanks again for taking the time to talk to us today. Your journey is really inspiring. It looks like you have a really bright future ahead. And I am personally very excited to learn more about what gets revealed through the Titan research. So please continue to keep us posted through Twitter, and we'll have to get together sometime soon. Maybe invite your friends and do a little group hangout session.
Of course, of course, no problem.
So thanks so much. Have a great rest of the day.
You too.